Costumes are complex entities of different elements: body, material, agency, and context. Garments embedded with electronics have a strong performative connotation as they can move, change shape, emit light, sound, or sense. They represent great potential for designers to explore clothing as social interaction, emotional sensing, biomimetics, or virtual environment. Electronics give costume new functionalities and blur the frontiers between performer, costume settings, prop, and puppets. They raise the very question of costume's physical materiality and change the perceptions of performers' bodily, experiential, and conceptual limits. In continuation, I will show a selection of most innovative wearables from fields of fashion, performance, and contemporary art that have strong scenographic and dramaturgical potential. I will explain each example's agency in relation to electronics they embed. Most examples are complex textile garments containing many sensors and actuators, activated by external or internal stimuli that can be processed instantly or delayed, and manipulated physically at distance or wirelessly. The electronic components make them responsive, active, or even interactive, so all examples have agency in most literal sense. I classify them in three different groups: body, material, and context. Garments in this group are activated by the wearer's internal inputs, like movement, gestures, touch, voice, or biometric data, like breathing, heartbeat, temperature, or perspiration. Some garments create intimate environment or scenography that interact with wearer's emotional state. Most examples have clear external agency for everyone to see or hear, while the agency of others can only be perceived by the wearer. A remotely controlled flying dress platform is moved by 6 big drones. The wearer's feet don't touch the ground, the garment is wearing the wearer. This costume is activated by dancer's movement. Textile reacts to movement, but it doesn't move in accordance with dancer's choreography. It seems to have the will of its own. A wearable bustier and a prosthetic leg turn performer's body into a fantastic creature instrument. 6-axis accelerometer and gyroscope can track movement and interact spatially and sonically with performance environment and participating audience through open source software. This ironic garment is using data from speech recognition system and can analyze voice stress. When a lie is detected, the dress lights up fully and delivers an electric shock to the wearer. This therapeutic garment is integrated with wireless sensor network that uses nanotechnology and microfluids. It senses wearer's body heat and other indicators of stress and releases aromas to boost the limbic system in the brain or deodorant when sensing the sweat. The dress, designed as second skin, simulates a blush, conveying wearer's emotional state and physical responses by projecting them on the costume surface or in space around her. Undergarment layer is equipped with heart rate, temperature, and perspiration sensors and LEDs that individually project colors and shades onto the bubble-like surface of the outer skin screen layer. These wearables are kinetic atmospheres that behave as if they were living architectural organisms with an auditory, visual, and tactile sensory quality. Garment generates sound that is manipulated through sound software and interacts with the participating screen space through motion capture and 3D animated video projection, thus creating a dialogue across the network with other remote performers. Garments in this group are made of innovative materials or give the illusion of immateriality. They are made with temporary tattoo, smoke, two-phase foils, motion-tracked body mapping, or augmented reality that question costumes' very physicality and blur the frontier between body, costume, and scenography. Removable adhesive tattoo circuit transfers data and lets the wearer or somebody else wirelessly control devices directly from the skin by touching it with bare hand. This dress is made of two-phase foil. It reacts to electrical discharge activated by proximity and light sensors embedded in the dress. When someone approaches the dress, the foil gradually turns from opaque to transparent. When someone takes a photo of the dress with a flash, it becomes fully see-through for an instant. This dress too is activated by proximity sensors. When someone steps into personal space of the wearer, the dress creates a veil of smoke, obscuring borders between her and surroundings. Smoke can be scented, so anyone can smell and taste the dress while inhaling it. Background behind the person is filmed and at the same time projected on the front surface of the cloak made from a special material, thereby making the garment invisible. This immaterial costume is made by mapping on the moving body. Performer wears a projection which moves in unison with her dancing body. Skirt, made of 70 smartphones, acts as a high-definition 3D screen. They are pre-programmed and synchronized to mimic wearer's surroundings with moving images. This unwearable garment is an augmented reality prototype. The wearer and the observers can only see it on smartphone screen with the help of special glasses or feel it with a special glove. The garment's design changes continuously, depending on wearer's biometrics and social media posts. Garments in this group act in a more scenographic context or as a character. They are activated by external stimuli that comes from the space around the wearer. They can be activated by movement, proximity, gaze, facial expressions, music, touch, or online data. Can be activated physically or remotely by a distant observer, or interact with other physical things or digital data. These dresses turn off ambient lights and illuminate when someone's looking directly at them, providing the wearer their own personal lighting. Eye tracking systems embedded in the dresses wirelessly trigger switching off the lights independently of the wearer's will or actions. This shirt helps deaf people feel music thanks to 16 microvibration motors embedded in the fabric of the garment. The shirt receives the music that the orchestra is playing wirelessly and in real time. Transformed in data, for example, violins can be felt on the arms and the drums on the back. Entire composition comes to life as a series of haptic sensations across the torso of the wearer. Sections of the cape move like waves depending on the focus of the spectator's gaze, activated from a distance. Small eye-tracking cameras are hidden beneath the 3D printed material embedded with small motors. Besides wearer's movements, this shape-changing garment can use an online weather station data like wind velocity and direction, which activate 14 vibrating air pockets to modulate its volumes and surfaces. This garment is capable of mimicking animal behavior. Inspired by cat, dog, or mice fur, this dress bristles its surface as a defensive mechanism or purrs when someone strokes it. The outfit is equipped with a facial expression tracking technology, an interactive pneumatic inflatable system, and a forest of fiber optics embedded in silicon that react by movement and sound. Garments that are made from magnetic cassette tape fabric serve as an old-school music player. Music, personal stories, or poems start to sound when the surface of the garment is caressed by a gloved device. These interactive costumes are reacting to each other's proximity and variation of distance. The dancers use the flowing evolution of light patterns as a visual cue for adapting their gestures and inspiring their choreography. Some applications of electronics in costume design. Costumes as autonomous moving source of light or as autonomous sound system let performers control their environment and settings with no need for external technicians. Costumes that amplify performers' small gestures, subtle expressions and emotions like respiration, heartbeat, tears, footsteps, and the interactions between performers like touching, caressing, hugging, make theatrical experience more immersive and inclusive also for visually or hearing impaired spectators. Identical costumes for performers and spectators can enhance sharing the same experience, empathizing with characters, feeling haptically what performers feel. Electronics can let spectators interact with performers directly by manipulating electronics embedded in costumes via their smartphones. Costumes for fantastic creatures, animals, hybrids, human puppets. The ideas of Uber marionette, obsolete actors, and non-actor-centered dramaturgies. Augmented reality, virtual environments, mapping, or holograms enable instant costume changes, body morphing, rapid aging, and disintegration. Light superstretch under costumes with integrated cooling, heating, and perspiration prevention that can correct performers' posture, positioning in space and lighting, or help orientation in dark. Pre-programmed costumes for less rehearsals, quicker training of substitutes, costumes that prevent injuries, give massage, and enable faster body and voice regeneration. Research costumes for investigating of acting and dancing methods, acting versus non-acting, and research of concepts of wearing versus being worn, manipulate versus being manipulated, and material versus immaterial costume. A lot is being written about great advances in wearable technology and about commercial potential of wearables. But one thing is reading about it or watching it on internet, and another trying on or making the wearables myself, like these few examples here. Majority of wearables on the market are just overpriced appendix to smartphone applications for indulging self-quantified fitness culture. So hacking cheap electronic knockoffs and online tutorials are the easiest way to learn. There are many downsides to wearable technology, especially with hardware, as there is still need for cables which are not elastic, short-lasting batteries which cannot be washed, and connections that are not resistant enough to withstand stage performance without constant maintenance by an electronic specialist. Sadly, we're still some years away from being able to buy half products like iron-on elastic pre-programmed circuits that could speed up the electronic costume assembly process. But components are getting tinier and cheaper by day, and software programming is becoming more comprehensive for non-programmers, so I think it's high time for costume designers to get acquainted with electronics as a new tool in our creating.